Hi, I'm Avery Fiore, the SAS VEX captain at the time this video is being recorded, and in this video I'll be explaining some things to consider when carrying an intake for this year's game, Spin Up. We'll be making a sketch so I can explain some things more clearly. Do not simply copy the sketch that I'm about to make, change things based on what your team's design is. For instance, if your team is using a combined intake and indexer, you'll want to combine elements from both of these videos when creating your planning sketch. And note there's also not only one way to do this whole process. I simply personally find it's easiest for people learning to CAD to plan out things in a sketch before actually CADing stuff so you can visualize it. So I went to create sketch, right? I'm in my intake file, make sure you're in the correct file when CADing this. And I want to create a side profile. Now I could have also do a top profile for the intake. Now I'll show different parts of the intake, but I feel like the part that needs to be planned out the most is from looking at the intake from the side. Okay, so looking at the cube, I can see that this side of the cube is the right side, so I'm going to click on this plane to create my sketch. Cool. Okay, sometimes a problem people run into is their grid is not being shown, so you want to check mark sketch grid. Okay, so what do we have here, right? We're looking at the side profile, and we're going to start by drawing in a disk. And we're going to assume this red line is the ground here. Okay, a disk from a side profile is going to be 20 millimeters by 140 millimeters. Note my default units right now are in mm. Are in inches. So in order to make sure I can type dimensions in millimeters, I just type mm, and well, it converts the dimensions for me. Right? If your document settings are not in inches, you want to go here with the pencil tool, change active units, select inch, checkmark set as default, and then you're good to go. Okay, you want to be counting in inches because apart from, I guess, the dimensions of this disk, all other dimensions will probably be in inches for this sketch. Right, but again, 20 mm by 140 mm. This is according to the game manual, which hopefully you read. Okay. So now the first point of contention is, we're gonna have some kind of wheel here. That's usually how it's done, right? But we don't know how big this wheel is gonna be, and we also don't know where exactly it's gonna go. So here are some things to consider. Right. We have to look at what our different options are. If we go to the V3 library, go to motion, go to wheels. All right, we have some different wheel sizes to choose from. So when using an intake, you either want to use one of two wheel types. You never want to use an omni or mecanum. Okay, the types of wheels you want to use are either a traction wheel or a flex wheel. Okay, a traction wheel is very solid. What you see in the CAD is what you get in real life, right? It's going to have this fixed diameter. It's not going to compress. And, well, sometimes that's good for certain applications, but probably not for this year. And I'll show why in a moment. On the other hand, we have these flex wheels. Okay, these wheels start with some kind of fixed outer diameter, but they are able to compress and become smaller because the sides of the walls that you can press into, it's made out of rubber. Okay? So what do you want to consider when choosing between these two different wheel types? Well, first I'm going to draw in another line here. Okay, and this line is going to represent our kind of ramp, backboard, right? And let's say it's 40 degrees, again, do this based off what your design is. And the length of it doesn't matter so much, we just want to put that down there. Okay, and I'm going to draw in another disk. For this disk, I'm not going to go to rectangle again because this rectangle is going to be at an angle, so I'm going to go to rectangle and 3-point rectangle. We'll start the origin, go out to here, okay, this dimension is 140 mm. Okay, I click down, I make sure I am on this line representing the ramp. And I go out this direction, 20 mm. And I click enter, and there's my second disk. Right? So, what someone might think is we can just do something like tangenting this wheel to these two sides. Okay, and let's say hypothetically we do that. And I'm also going to give this wheel a dimension, so let's say it's a 4-inch traction wheel. Right, okay, cool. Now here's where the problem comes up. So let's say I create another rectangle, okay, and representing an in-between stage between these two positions for the same disk, right? This dimension is going to be 140 mm. I want it to go to that line, so when I see that cross, I know it's on this line. You don't necessarily have to draw in this third disk for dimensioning things, but I'm just trying to make a point. Okay, and then this height of this is going to be 20 mm. Right, and these lines are blue because they're not fully constrained. Black means it's fully constrained, and that means you're doing a good job of your sketch. Blue means you need to further constrain it some way, right? So we've got this in-between position. And as you can see, this disk now very clearly goes into your wheel. That can cause a bit of a problem, okay? Between a solid traction wheel and the disk, right? The disk is made out of a pretty hard foam, but it's still foam nonetheless. So you're going to end up bending your disk, okay? I believe in the game manual there's a rule against damaging game elements. I don't know if this would really necessarily count, okay? But if you do deform the disk, that's not good because it's going to not fly off your flywheel very well. And just respect the competition. You don't want to damage things unnecessarily, right? So that wouldn't be too good. Now would it be? So different ways to solve this problem, right? If this wheel here was a flex wheel, well then that doesn't matter. Between a flex wheel, since a flex wheel is a lot softer, and this disk, the flex wheel will give first, okay? And it will just, decrease in diameter, and you'll be able to intake in this disk, right? No problem. The other thing you could do is you keep this as being a solid traction wheel, okay? But instead of putting these tangents here, right, we can say that maybe there's some kind of arm. The arm goes out to over here, right? I don't know. I'm just going to fix this point here, never do that, but I'm just trying to make a point, right? And I'm going to delete this horizontal constraint. Who would let me? Oh my gosh. There we go. Cool. And so that point's fixed there, but let's give it some set dimensions. So something like that. The point is, you could create a 1-bar pivot arm that's pivoting around some point, right? And this wheel could then go up and down. So when it's in this position, it's able to contact that disk, as it's coming in. But as disk is trying to transition into the robot, the wheel can pop up a bit. That allows for a smoother intake, right? And your disk will find its way into the robot, but as it becomes flatter again up against the ramp, this roller goes back down, okay, and starts contacting the ramp. So that's another way to do it. You could even combine both of them. You might do this if you want just a really smooth intake and you have time to do that, right, and CAD it. Or maybe your angle is super high, like, I don't know, yeah, let's say 60 degrees, right? Then you can look at how far this intermediary disposition is like pushing into the wheel, right? Your wheel can only compress by so much, so you would want it to be able to pivot up. And a pivot isn't necessarily like this, right? Maybe the pivot is closer, maybe the pivot is further away. That'll affect, how this thing rotate around. Now, some things about the pivot idea, if you were to go with it, is that let's say this line here, right, is representing your 1-bar pivot arm. Well, then this dimension would have to be, some kind of multiple of 0.5 inches because all of the holes on different pieces of metal are spaced by 0.5 inches, so this should be 7 inches. Okay, and then it will work, pretty well. Okay, and this pivot shouldn't just be in some arbitrary position. You should base it off of something, and we're going to get into that in a bit. Okay, but for now, I'm going to delete the pivot. I'll come back to it later if you want to do that. I'm also going to delete this intermediary disk because it's just there to make a point, but we don't necessarily need it. All right, and I'm going to change this back to 40 degrees. Okay, so now your take wheel is like that, okay? And, depending on one way or another, you need some kind of compression. So you always need to make sure those wheels contacting the disc. If it's a flex wheel, right, you can actually go into the disc. And for the sake of argument, I'm going to assume that's what you're using, okay? So now we have to dimension the distance between the disc and the ground. And you want the wheel and the ground. And you want the wheel to go into the disc a tiny bit, okay? Because when you look at the disc, there's actually like a pocket on it. Okay. Go here. I'm gonna go to game elements. Okay, I look at this disc. You can see that it actually, kind of dips down a bit in the center. Here, kind of see if I go to slight angle where that is. Okay, so you actually want, even if it's like technically in the disk, it might still only be contacting the surface of it. So you want your intake to be able to go into the disk at least a tiny bit. Now, where do we position this? So if it's on a pivot arm, works differently, but let's say it's mounted statically on some structure that's probably going off your drive base, right? Then we need to think about what are some different drive base hole options. So, let's say your drive base is using a 4-inch diameter wheel, right? And it's tangent to the ground here, like that. Okay? Wherever it is, right, you're going to have some different options for holes. Because let's say this is your C channel here. Okay, and I'm just going to put this in. You don't have to draw this. Okay. There's going to be these lines of holes on this sketch line here, right? And they're all spaced 0.5 inches away from the center of this wheel. Okay, it could be, anywhere. Okay, there's also additional lines of holes. Here. All right, and let's say this is going to be 0.25 inches because that's, the distance from top and bottom. Okay, could also put something on one of these holes. Right, so that actually gives us 3 different heights to work with. The distance from this wheel doesn't matter so much because, the wheel for the robot could be here, could even be here, right? Because we're looking at this from the side view, so what that would mean is, the wheel would be closer to us, okay? And the wheel on the far side of the drive base is like really far away from us, and the intake could be in between those 2 wheels in your robot. Yeah, but we have these 3 different heights to choose from. I take the measure tool, I can see that should be 1.75. Why is it not? Oh, okay. Sorry, give me a sec. Should be 1 inch. Okay, yeah, so we can see that from here to here is 1.75 inches. Right, from here to here, it's going to be 2. From here to here, this is 2.25 inches. So you got a whole bunch of different options. Okay, I'm going to delete all this now. Yeah. Okay, so you could use one of those options. There's also other options. You have to think about how C channels join together and different heights you could use. But effectively, I mean, I guess that kind of means that you just stack two C channels on top of each other. You can get almost any multiple of 0.25 inches. Okay. So, let's say we use 2.5 inch dimension, right? So that's going into the wheel bit. That should be good. Okay, then I'm going to dimension it to this wall. Now I'm going to do something interesting where this dimension here, right, I'm typing it in, I'm going to click on this other dimension here. Now why am I doing this? Because let's say I want to change the compression later. I realize I want to move this half a hole higher to 2.75 inches, right? This other dimension will change for me. So how did I do that? I'll show again. Right, I did dimension this line to this dot, okay? Something to note about these dimensions at an angle, or no, it's fine. Right, I click on this, and I click on the other dimension, okay, and it constrains it. Okay, so that is roller 1. Well, yeah, your intake usually only has one roller. Okay, so we've thought through that. Now, the other way this could go, leave a lot more room to play around with this is all on on some kind of arm, right? And your arm, I don't know, could go there. This pivot could be anywhere, right? Like, I mean, this pivot has to be some kind of dimension from the ground that's a multiple of 0.25 inches, probably a multiple of 0.5 inches would be better, because there's gonna have to be like some kind of tower here, right? It wouldn't touch the ground. It would be staying on top of the drive base, but I'm just drawing it to the ground because it's easier for me to sketch this out. Right? This would have to be some kind of 0.5 inch multiple. Right? And this could be many different places. Could be here. Could also move it normally, let's say. There we go. Right, yeah. Okay, and this would be on some kind of pivot. And what you would have to plan out is to have some kind of stopping structure. Maybe I'll just draw a circle to represent a standoff. Right, that makes sure it stops the arm from coming down too far. Okay, and you also need to have rubber band tension to pull it this direction, so it doesn't just bring up on its own randomly. You want it to be in contact with these discs, with a decent amount of force, but not too much. So you would also have, some kind of rubber band, maybe up here, pulling down to the left. Okay, and maybe this bottom left point is connected to your drive base, and the top right point would have to be connected onto this arm. Okay, and then what that would do, okay, is it would allow this to pivot up and down. Right. Another thing you do, I talked about this briefly, is you need to dimension this line. Another thing when you're dimensioning, you want sometimes to be on the dimension of the line itself. If I click down here, I'm getting the horizontal length. This is the actual distance of the line, and I do this by moving the mouse further to the left. Okay, and you want this to also be an increment of 0.5 inches because it's using the holes of some kind of C channel. And so yeah, made this work. Okay, so that's some things to think about for the intake, right? And how do you turn this into an actual design? Well, after you finish your planning sketch, I'm going to revert to a simpler version where we have it statically mounted. Like that, we click Finish Sketch. Okay, cool. So we know what kind of wheel we're going to use, right? We also know the kind of structure we're going to use. Okay, if you ever need to look back at the dimensions, you can right-click on the sketch and click Edit Sketch. It's going to be 2.5 inches off the ground, so that means that's higher than that piece of C-channel from the dry base I drew earlier. So that means I'm going to have to stack a piece of C-channel on top of the dry base and use one of the holes in that C-channel in this instance. Okay, depends on what you're doing specifically for your own design. Okay, so let's say that's done. Then, you know, we want to create some components. We want to create, for an intake valve, we want to create a structure component. Okay, we also want to create a roller, right? There are two different components. Structure is going to house your C channel supporting all this. Your roller is going to house the wheels. You're probably going to have multiple wheels beside each other. Okay, or maybe it's just a few. Depends. Up to you. Right? Everything you put in the roller component is going to be something that moves. So that would be like the axle, right? Structure component is going to have everything that's going to be stationary. So that'd be like C channels and bearing flats. Okay. One more component you might want to consider adding, okay, is a gearbox. Now, for an intake, a gearbox will be probably pretty simple. If I were to draw a view from this perspective of it, okay, so our intake is like that, just so I know. Okay, it'd be like, you know, C channel here. I'm not going to put in dimensions, I'm just going to show you generally what it looks like. Okay, be like a C channel there. And then if you're going to do a gear ratio, you want to do like about a 3:1 gear ratio. Okay, and you're going to have a little gear, 12-tooth gear here, 36-tooth gear here. Right? Another C channel, every gearbox you want to cap the gears on both sides. Right? And then you'd have an axle running through here, an axle running through here, so this gear. Okay, and there would be a motor here because of gear ratios. This is the driver gear, this is the driven gear, right? And that creates your 3:1 gear ratio because this is a 36 and this is a 12. Therefore, increasing the torque and decreasing the speed of your mechanism. Okay, so this final line here, I could select all of this. That final line there should be lined up with okay. So this final line here should be lined up with your intake roller, right? Because this axle is what's going to be turning your wheels. So I actually drew this slightly inaccurately, but you get the general idea, right? Creating this kind of gearbox is more easily done when it's statically mounted, your roller, okay? But if it is going to shift, then, well, you have to think about, do I want to use a chain instead of some gears to, you know, create a ratio? You can still create a ratio with sprockets. You just have to use different size sprockets and pretend the sprockets are meshing together. Okay, this still creates a sprocket ratio, which works effectively the same way as a gear ratio, right? You have to consider, do I want to put a big bulky gearbox on the part that's moving, or do I want to, you know, put the motor on something stationary and just chain it all together? You know, that's something you're going to have to consider. Okay, so those are just some thoughts on how to CAD an intake, but what I'd start first at this point is go to structure, put in some C channels, right? Okay, then to go to your roller, put in some wheels, okay? If you're using a gearbox, you know, you'll also have to CAD the gearbox. So that's it for intake.